Welcome to the Ansys Fluent Academy Beginner CFD Series. This is part 1 of a complete CFD learning journey where we will cover a variety of classic simulations using Ansys Workbench and Fluent. This is ideal for students, beginners, and anyone looking to build a strong foundation in computational fluid dynamics. In this series, we will explore topics like steady-state heat conduction, laminar and turbulent pipe flow, force and natural convection, boundary layer growth, supersonic flow over a wedge, flow past a cylinder, quad flow, Bernard convection, and more. In this first video, we are starting with a steady-state conduction problem, and you will learn how to create the geometry using a SpaceClaim, prepare the mesh using Ansys Meshing, set up simulation parameters in Fluent, visualize results like temperature, contour, and gradients. So, where you are new to CFD or brushing up your basic, this series will help you step through each simulation clearly and confidently. So please don't forget to subscribe and check the playlist to follow along. So let's jump into Workbench and start with the geometry. Okay, so this is the Workbench window. You will see there are different windows here. So we will go through many of them during this video series. In this video, we will see how we can model the heat conduction, steady-state conduction. For this series, we will use this analysis system, Fluid Flow Fluent, and we will go through different options in the Workbench. But before we start modeling, let's first take a look at the input details of our steady-state conduction problem. We are simulating one-dimensional heat conduction through a 2D rectangular solid with heat flowing from left to right, from this wall left to the wall. The length of the solid is 1000 millimeter and the height is 100 millimeter. We are assuming the material is aluminum with a thermal conductivity of 202.4 watts per meter Kelvin. On the left wall here, we apply a constant heat flux of 1000 watts per square meter. And on the right wall here, we fix the temperature at 300 Kelvin. And the top and bottom boundaries are set as symmetry, meaning there is no heat transfer vertically here in this y direction. So this enforces purely one-dimensional conduction from left to right here, and we will see in our simulation later. And to study mesh sensitivity, we will run 3 simulations with different mesh sizes. The coarse mesh has 30 division in the x direction and 3 in the y direction here. The medium mesh uses 4D in this x direction and 4 in the y direction, and finally fine mesh, which you are seeing here, 50 meshes in the x direction and 5 in the height. So this parametric approach helps us evaluate the effect of mesh density on solution accuracy, particularly in resolving temperature gradient. So from this simulation, we will extract the temperature distribution along the solid, as you'll see in this final result, and calculate the temperature gradient and the heat flux, and visualize everything using contour plot and the line graphs. So let's go back to the Workbench and start our simulation, creating the geometry, meshing, and finally start our simulation. Okay, so first of all, this is an unsaved project, so we need to save project first. I can go to the file and then save, here. So I will go to the desktop and use this folder and write the name, Conduction, and use the save button. So now this project has been saved. But one thing, maybe it is good to know, if you want to change this, I mean, when you click here on this Save As button, it will go to a folder automatically. If you want to change this folder, you can go to the Tools and Options, and in the project management, you can just remove this check mark here, and then I mean, select your desirable folder where you want to actually save your files. But I will keep this one. But if you want to change that actually directory, you can come to the project management here in the options and change this folder. So for now, I will close this one. But now we can start. First of all, I will select this system, Fluid Flow Fluent, and drag it, just drag it here in this window of the workbench. When it is red like this, so you can drop here, and now you have this package here from Geometry, Mesh, Setup for Fluent, and Solution and Results. You can also change this project name to Conduction, for example. So the first step to start a project is having a geometry. In this case, we are simply create a geometry in a SpaceClaim. If you right-click in this box, you will see that you have different options like SpaceClaim Geometry, Design Modeler, which is a little bit older than this SpaceClaim, and New Discovery Geometry. Also, you can import your geometry from here. But in this case, I'm going to use this SpaceClaim geometry. But as this this problem, this 1D steady state conduction problem is a 2D geometry. So after clicking on the geometry, you will go here to the properties of your geometry and just change this 3D to 2D. Then again, right click here, and this is the default software for the geometry. If you double click on the geometry, this default system will be open. But I just click on the new SpaceClaim geometry and wait for a few seconds to have it open. But when it is working, something here in the workbench, you will see here in the bottom left of this window that something is happening, and so you cannot do anything else. So we just need to wait for SpaceClaim. So now SpaceClaim has been opened. So we can work here in the SpaceClaim here. So based on this geometry, we want to create a rectangular like this in the XY plane. So first of all, you will see there are different tabs here. In this case, we will start with the sketch mode, and you will see there are different mode here, and now we are in the sketching mode. If I click on the rectangular, so it is active, and now I can create the rectangular here. As I said, we are going to use the XY plane. So to do so, we will go here on the bottom, and you will see you can select your new sketch plane here. So I will click on this one, and then if you bring your mouse here near this item, so you can simply select your sketch plane. I'm going to use the XY, so I just click here, So now I'm in the XY plane. And to see in a plane view, you will go here and click on this plane view or use the V short key on the keyboard. So now I can draw a rectangular here. If you bring your the mouse here near this center, so I can just simply click here. There are few options here that we will go through. These ones maybe later in other cases, because this is just a simple rectangular. I will just click here, and just one thing, you can look at this area. There are some few message that it can guide you what you can do. First of all, I will select this datum point here, and then I can create the rectangular here. So now it is the length of this rectangular is 32 millimeter, and if you want to change this one, use the space on the keyboard and then type the dimension that you want. In this case, it is 1000 millimeter, and if you use the tab key, it will go to another dimension, which is 100 millimeter. And if you keep the mouse button here and type your dimension, you can simply click on the enter on your keyboard. So now this rectangular has been created. So to exit from the sketch mode here, you can just simply click on the escape on the keyboard, or you can go to the design and press on the 3D mode. So I will do here, do this one and click on the 3D mode here. And now you have a surface here. So we can extract this, export this one to the next step, and that's Ansys Meshing. So you can simply change this name. For example, I can rename it to plate. But before exporting to Fluent to the Ansys Meshing, you can specify the boundary conditions, at least the name of this boundary condition. So to do so, you should go to the Groups tab here, click here, then you can just simply exit from the Pool tool, because you have created a surface. So press escape on your actually on the keyboard, and then we are going to have this boundary condition name here: wall left, wall right, and symmetry top and symmetry bottom. So to do so, I just select this one here. So you will see this create will be activate when you click here, or you can use the Control G as the short key. But here I will click here. Then you can write it as wall left. So the same process I can do for other boundary, but a little bit faster. So I click here, use Control G, then write the wall right. The same I click here in this edge, Control G, and then symmetry. I will copy this one here, bottom, and then click here. This time I will click on this create NS, and then symmetry top. So now I have this 4 boundary condition for left, right, bottom, and top. If you bring your mouse here, so you will see which one is wall left, which one is wall right. It will be highlighted here, you will see, or symmetry bottom and symmetry top. And one more thing I can show you here is the measurement tool. So if you go to this measure tab, you have a tools here like called measure. You can use E on your keyboard as a short key. So if you select on one of this edge, you will see the information. It is 1000 millimeter, and this one is 100 millimeter. So if you select on this surface, you will see the area of this rectangular will show you in this case. And one more thing, you will see the dimension, the unit of the length is in millimeter. So if you want to change this one, you should go to the file and then SpaceClaim options. And then if you go to the units, so you will see this length is in millimeter, but you can change it to centimeter or meters because it is in the metric type. You can use the imperial type, and then you have access to other type of unit. But in this case, I will keep this millimeter as it is and cancel this window. So in this part, you saw that how we can create a simple 2D geometry like this, and how we go to the group and create some name selection as our boundary condition to define our boundary condition later. So we will separate it from each other, and then use the measure tool to measure the different dimensions in our geometry, and finally how we go to the options, SpaceClaim option, and change our unit. So now it's time to go to Ansys Meshing. But the thing is, when you are working in the Workbench like this one, and one more thing, you will see now this task has been completed and it is green. So the thing is actually when you have done your work in the SpaceClaim, you don't need to save the file. You can just simply close this SpaceClaim. So I will do and close this SpaceClaim. So I don't need this one. I will bring Workbench on top, and as we save our Workbench, it will save in the temporary folder. And if we save the project again, so the geometry will be saved in the directory that we have saved our file. So if I go to the folder that I have created for this project, the state conduction, so you will see there is a backup file here and one folder related to the file that we are creating in this project, the conduction file. If I open and go to this DP0 and then FFF, so this is the folder that we have for our SpaceClaim file here. So you see we close the SpaceClaim, but the Workbench saved the actually this geometry file here. So now it is time to go to the mesh, and so you can just simply select this mesh file here and then use the edit and wait for a few seconds. You will see this meshing is starting to open. Okay, so now we are in the meshing part, Ansys Meshing tool. So we can start to meshing our geometry. So you will see the geometry has been imported here. Also here you will see the file. But so as this task has been done, we can go directly to the mesh and start this Ansys Meshing to mesh our geometry. Okay, so let's start with the meshing. There are different tools that can help us to have a very structured mesh here. So you can use these tools here to have a better structured mesh. If we just click here, we can generate the mesh actually here with clicking on the generate mesh with the default setting. So if I generate the mesh, you will see it will create the mesh like this. You can right click here and then clear the generate data, press on yes, so all the meshes will be deleted. So you can change this default setting to another value. For example, I will change this default value to 0.01 like this one, and then click here on the generate mesh. So you will see some smaller grid here in this geometry, but I will click here and clear this generated data also, because I'm going to use some tools here in the insert to actually control the size with this actually tools here. So first of all, I will go to the insert because as I said, we are going to generate some mesh, controlled mesh like here. We need 1, 2, 3, 4, 5 grid in the y direction and 50 in the x direction. Then we will change these values to other meshes. So because of that, I will just select some of these tools here to control our mesh. So first of all, I will use this sizing. So if you keep your mouse on each of these tools here, you will see some explanation. So this is control size related settings such as element size, number of division, and so on. So you can use this help to see which one is for what purposes. So first of all, I will select this sizing. I'm going to give 5 elements to this height here, this side and this side, for the wall left and wall right. So when you click here, there are 2 options here. You can select the geometry selection, which is default setting here. So then if it is on here, so you can just click your geometry here, like this face or like this edge. If you bring the mouse near the edge, so the shape will be changed to the edge, and if you bring it here, it will change to face. And this is in the 2D geometry. The other option is name selection. If you select here, you can click on this window and select the area that you have created before in the SpaceClaim or other geometry tools. But in this case, I'm going to select these 2 edges together, and I will select the default setting, geometry selection. So I will just simply click on this edge. So if I just select here and click here, apply, so you will see this geometry has been selected, just only 1 edges. So if I click again in this window and bring the mouse button here and click here, so you will see you can add this edge also to this selection. So I will select here, and then you'll see it will be changed to 2 edges. You can also do one thing. You can, for example, if you select 2 edges and you want to remove one, So again, you can select here, click on this edge, and then this time you can remove this edge from the selection. Okay, so in this case, I need these two edges together. So I will select this one, and then again click here, select this, add to selection. So you have two edges. The other option is suppress. You don't need to use this one if you select this one. So you can suppress this control tool here from the meshing. There is the suppress tools also here. So if I select this one, this control will be disabled, and it's not included actually in the mesh generation. So the other case, I need to do the same for bottom and top. So I will click here, insert sizing, and this time I will select this bottom edge. You can also hold the control key and then select this edge like this one, then click on apply. So you will see this two has been selected. But the thing is, I'm going to edit this first edge, and then again here, because I forgot to change the default setting of this part. Okay, so for the first two edges, the type of this tools is element size. It means you need to specify the size of each division here. But in this case, I'm going to use another option, number of division. So I will select this number of division. And as I said, I need 5 division here. So you will see I have 1, 2, 3, 4, 5 in these two edges. But as I said, I'm going to check the sensitivity of the number of cells. So I can click on this box here to make this number as a parameter. So then after finishing this part and starting the simulation, we can change this parameter and then simulate for different number of division. So if I click here, you will see one box will be added in the workbench, and if I click here, you will see this edge size number of division has been added as a parameter here. I can also change this edge size number to, for example, Y direction or everything you want. I will close this one for now. Go to the meshing, and so this is a parameter here. I will do the same for this bottom and top edges. So I will change this element size to number of division, change it to 50, and then click on the number of divisions. So I have two parameters here. If I go back here, so now in the parameter, I have two parameters. This is edge size number of division in the Y direction, and this is in the X direction, P1 and P2. Okay, so I can now generate the mesh, but you will see maybe it's not your desirable mesh if I generate the mesh. So you will see after a while the mesh has been generated here, but you will see the number of division has been changed, and it's not 5 and 50 maybe in this direction, because I changed this element size to a small value. So in this case, this value is more precise than this control tools. So the Ansys Meshing will select this one, and so this mesh generation is based on this one. So I can just clear generated data again, change this one to, for example, we can try to 6, and then generate the mesh. So now this time the division is correct, 1, 2, 3, 4, 5, and here it should be 50. But there are some rectangular or 3-edge meshes inside this one. So we need to control these meshes here inside this one. So there is another option we can simply select and use. So in this case, I'm going to control the face meshing on the face. So I will select this face meshing. So enable the generation of a free or mapped mesh on the selected face. So I will select this one. Then again, geometry selection. I will click on this face and click on apply. In this case, we can check what we have. This is triangles or quadratic meshes. So this is the default setting here that we have. So I will select this one, and you see you can select that this you need to apply a mapped mesh or not. So I will keep this one as yes. And this time, if I select here and just generate the mesh, you will see you have your desirable structured mesh with the number of division that you are going to use. So that's the thing that you have. And also after, so this part has been done, but you can check your name selection here, as you have imported these parts before from SpaceClaim to this Ansys Meshing. You have this part here, but if you forgot to create this boundary names in the SpaceClaim, you can also create these ones here. So you just simply click on the insert and name selection, and then select the boundary condition that you want. Okay, so now it's time to transfer this mesh to our Ansys Fluent. So there's an option here that you can update this mesh, and then it will update in the Workbench, as you will see here. If I bring this up, so you will see it's not completed yet. So you can simply click here and then click on the update the geometry, or you can close this Ansys Meshing and then click here and then update from here. So for now, I will go here, click on the update, and wait for a few seconds. So the mesh transfer to Fluent was done, and you will see this is changed to the green one. So without using the save, we can close this window. Now it is in the temporary folder of the Workbench, but to be confident about this file, we can save the project here. So now the mesh file also will be saved in the working directory. So if I bring this folder here, you will see again under this DP0 and under this FFF, you will see another folder like mech. So you can open it and you will see the mesh file that saved here. So now it is time to start our setup in the Ansys Fluent. So to do so, I can just click here and then click on the edit, and then this window will be open. I'm going to use double precision. You don't need to do this, but I would usually use double precision, and then you can change your solver processors to, for example, 4 cores. But I will keep this one as the default one, and then click on the start to launch the Ansys Fluent. So you will see this part is still starting the Fluent. Okay, now the Ansys Fluent has been opened, and you will see here. You will see the geometry imported here. One thing that before I start I can show you, as I usually work in the dark theme of the Fluent, I will go to the file, and then here, when you go here, you can change your actually theme of the Fluent to other color, dark mode, or default mode. So when you went here in the file and then in the preference here, you can go to the appearance and change this default to the dark mode if you want, and you are convenient with this dark mode. So I will change this one, and then we press on the OK, and then again OK, and I will close this one. Sometimes when you change your color theme, so there are some few mismatching on this tools here, but this time it is okay. So if it happens, so you can just close your Ansys Fluent and open it again, so the problem will be fixed. So let's have a look on the Ansys Fluent. There are different tabs, tools, and options here, so you can select and work and customize your Fluent workspace. For example, in this case, I have selected all of this one, and all of these tools are active here. So you can simply change this parts and put everywhere that you want. So you can customize this one, or you can, for example, this is the mesh display, so I can disable this one so you don't have. So but as I work a lot with this option, so I will keep all of this open. You have also some of these options here on the right, and also if I extend this window, I have two window task here. You can customize also these ones. So in the outline view here, you will see it's like a tree structure, and you can go one by one, step by step here, and set your settings here inside the Ansys Fluent. You have also one console here under this graphic window. So if I bring it down up, you will see all the messages will be appear here, and also you have access to many setting an option. If you just click here and then type enter on your keyboard, so you will see there are different options, and for all of this you can go inside and type just like define, for example, and then enter, and again enter. So you are in the define, and under the define you will see many options here that you can access. You can go through those one and change your setting here. But in this case, we don't need to go through this one. It just was an explanation for this console. You can also select a part of this text here, for example, this dynamic. Then mesh, you don't need to type all of this. So if, for example, I type dyna and then click here, so you will see it will go to so I will click on I will type Q, the first letter of quit, and then press enter. So I will go out from this menu. Another option is that if I press enter, so you can, for example, select this text with your mouse, and then if you press on the middle bottom of the mouse, you will see this text will come here, and then so you can simply select and press on the middle bottom of the mouse, and then you have access to this text here, and then just press enter. But I don't need to this one, so I will clear this text and bring the console down again, and this is the graphic window. Okay, one thing that you can select from these tools here is this ruler. So you can show you the ruler of the Fluent. Click here. So it will give you approximate. I mean, it's a ruler, so you can just know about the dimensions approximately. In this case, as we are working in the millimeter unit, so I'm going to change this meter to millimeter. So to do so, to change the unit of the geometry under this domain, you can go to the unit, click here, units, and then if you click here on one of these texts, and because you are going to change the length, unit of the length, so you will click on, you will type L as the first letter of length, so it will go to the length, and then if you select here on the length, you will see the units, available units here, and I will select the millimeter here. Just select the millimeter, so you will see this unit will change to millimeter. So then you can close this one. So there are different units, like for example temperature. If I select type T, so it will go to temp, and it is in the Kelvin unit. We are working with temperature in this example, so we'll check. This is in the Kelvin, so I will close this window. If you want to see something about the minimum and maximum of the coordination of this geometry, you can go to scale. You can use this scale to change the scale, but it's a tool that you can check your minimum and maximum direction. So you will see in the X direction, the geometry will be start from the 0 millimeter to 1000. So the maximum X is 1000, and in the Y direction we have 0 for the bottom side and 100 millimeter on top. So this is the maximum value of the Y direction. So I will close this scale window. Now we can start the setting on the Ansys Fluent. If the first part is the general part, so I can just simply double click on the general, so it will switch from outline view to this task page. We check the units and the scale also. For the solver, we will keep this pressure based and we'll keep this default, and this actually simulation is a steady simulation, so I will keep all this default setting as it is. Then I will go to the outline view again. Okay, so now it's time to go to our model. There are different models here for the different type of simulation. In this case, we are just using the energy equation. So we need to activate this energy equation. If I go to the physics here, or from this model, I can activate this energy equation by click on the energy or double click here. So one small window will be open, and you will select the energy equation here, and then you will press on OK. So energy equation now has been activated, so you have access to different things in different window, like the thermal conductivity, material, or energy equation. So for other parts, we will ignore all the equations because it's just a conduction. Also, we can go to the control here or under the solution control, and under this control you can use the equations. You can also open it from this control part. If you go here, you have access to this equation. So as it is just the energy equation, we just deselect this flow and turbulence and select this energy as it is and press OK. So only the energy equation will be solved in the Ansys Fluent. So I will go to the next part, the material. But before that, so here we have first we have two material, one fluid and one solid. The air is the default material for the fluid, and in the solid it is aluminum that we are using in this problem. So I can open this aluminum and check as we activate the energy equation. So now we have this specific heat and thermal conductivity in this window, and the value is 202.4. You can change it, but we will keep in this tutorial. So we just check, and so I can close this one. After defining your material, you can go to the cell zone, and you will see because we didn't change in actually Ansys Meshing and SpaceClaim, so we need to change this fluid to the solid. So if you right click here on the fluid, as this is a solid, so you will change it simply to the solid, and you will see this solid will be, this fluid changed to solid, and the material for this solid is aluminum. So I will keep this one and apply, then close. Okay, now it's time to set up our boundary condition. So we'll go to the next task here. I will open this window, extend this window actually. This is the internal and this is the fluid domain, I mean the solid domain here. You can, to find each of this boundary condition or even this cell zone condition, you can just right click here and then display. You will see, so this is your plate here, solid, and you can now close. And for the internal, you will click here, display this one. So this is the interior for this plate. So you don't need to define anything. It's just a definition for the interior of this face. And then as we call this bottom and top edges as the symmetry top and symmetry bottom, so it will automatically, the Fluent know that this is a symmetry type of boundary condition. You can display this one also here, but you can use the add to also and add this one to the available screen. So I will do the same. So you will see this is the bottom symmetry. I will do the same, add to active window. So it will add here. And then we will go to the wall. We have two wall boundary condition, as we call it wall left and wall right. So it has been defined automatically to the wall boundary condition. If I display it here, this is the left side of the wall left, and this is wall right. I will add also to the active window. So now we are going to open this wall boundary condition. We double click on this one. So in this case, the boundary condition for the left wall is a heat flux, and as I said in the first of this video, it's 1000 watt per square meter. So you just enter the value and then click apply, then close this one. Then you need to edit this right wall here, so you will open it. But this time you need to change this thermal condition under this thermal to the temperature, as it's a constant temperature. So I will select the temperature, and this is the default 300, so it is okay for our simulation. So I will select apply and then close this window here. So all the boundary conditions also for this case has been set. So I will close this window also. Then in every simulation, we need to go to the method and set this one. We will keep these ones as the default. So I can go to the outline view again. Then control also, you can change these relaxation factors here. We'll keep in this case also. And then I will go to the monitor and residual here. If I open this one, this is for monitoring our residual and set the value here. I will keep actually in the Fluent, the default value for energy equation residual is this value 1e minus 6. I will keep this one. I will solve the simulation, and after that I will increase this size, and we will check the values together, because for the heat conduction like this one, this problem, it should be better to have a more precise residual to have a better and precise values and results. So I will keep for now this one, this default value. And then the next step is to initialization. So it means that you need to give some initial value to your equations, and then the solution will be start based on this initialization. There are two options, hybrid and standard initialization. So if you select the standard, so you can select one boundary condition for like wall left or wall right, and based on this value, the Fluent set the initial value to hold the boundary. But in this case, I will select the hybrid initialization. If I bring it a little bit up, so just I click on the initialize, and it will done simply. So hybrid initialization is done. So next step is to run calculation. I will go here, run calculation. In this simple case, you just need to put your number of iteration. I will set this one to 1000. It is super high, and after a few iteration, it will be converged with this residual value that we have set, 1e minus 6. So now it is ready actually to calculate. So I just click on calculate. So one window of residual will be open. So you will see the calculation has been completed. So I can press on the OK, and you will see this message that solution is converged. And if you check the value of residual, you will see it's under the 1e minus 6, and you have the scaled residual here. So after just 2 iteration, it reached to this criteria. So I'm going to decrease this residual value to minus 10, and then press OK. I will go to initialization again and initialize again. So I will press on OK. So again, run calculation, keep this value, and then I will keep this value because as you watched here, if it's reached to the desirable value, it will be stopped automatically. And so now I will start again the calculation. So this time after 10 iteration, it reaches to this value 6.08 e minus 11. So it is less than the defined value, and this is the new residual plot, and you will see here. Okay, so everything has been done in this simulation for the first value of this one. I mean, for the first mesh residual mesh definition. So now we can go to the result part and click here, and under this result I will go to the surface integral to have a report of temperature on the wall left. So there are different type of reports here. You can select minimum value, maximum value. In this case, I will select the actual area weighted average, and I will select temperature, and I'm going to see the static temperature on the left side of the geometry. So under the surface, I will simply select on the wall left, and I will compute. So you will see the value is in this case is 304.94. So if I go again to the residual and change this one to 6 and press OK, and then initialize again and run calculation. So after the convergence, so I can compute again. So this time you'll see this value is a little bit less than the previous value. So this is the previous value. I can copy. This is more actual, and so this is 304.94, but here in this case this is 304.45, so it's a little bit less than the actual value. So you will see the differences here. So I will delete this one. So one more time I will go to residual, change this to -10, okay, then initialize problem, and then run again, calculate, then again the correct value. So I will close this window, but one thing we can check actually this value as our output and save the output parameter. Then when we change here in the workbench this table, and for now we have just two inputs, which are the number of division of two edges. So then we will have an output also here, that when we change this input value and run the simulation, we will get some new values actually here. So let's do the same, save output parameter, and so I can call it as wall left temperature. Okay. Then I will click on the OK and close this one. So now if I go to the Workbench, you will see here this this value actually here has been created. So if I put new values for these two inputs, so and run the simulation, then the new value will be shown here. So now let's go to the just some simple post-processing. Most of this post-processing part are under this graphic. So you can use all of these ones, and also under these results you can select some of these post-processing tools like the contours, vectors, XY plot, and everything that you want to use for your post-processing. I'm going to use the contours here. But before that, one time I will go to the display mesh here. If I click here, you will see all the surfaces will be presented here. So you can simply display all this one, or just select some of this boundary condition, for example. So you will see you can select each surfaces and display here in the graphic. So now let's go to the contours. I will right click on the contour, select a new contour here. We'll call it as contour temperature. So we will see the variation of temperature inside this domain here. So first I change the name, then I will change this type of contour to temperature, and you will see there are different options. I'm going to use the static temperature in this case. Now I can select which surface or boundary condition or surface I need for show the contour. In this case, I'm going to use this plate. I will select this plate, and if I click on the save and display, so you will have this contour temperature here on the contour now, and there are different options you can use in the contour of this temperature and in other contours as well. For example, we can go and check some of these one by one. So now it is select as field. So you will see I can scroll, zoom in a little bit. So as you see, I can use this field. So it will be field, hold the selected surface. If I deselect this one, so you will see it's not filled, and there are just a few number of division of the contour here. The other parts we can go later, but some of these cases is, for example, this global range. It's not applicable in this case. Actually, when, for example, you have two or three different surface or more, so if you select this global range, it is showing this contour between the minimum and maximum value in whole domain. But if you just deselect this option, it will show the range of the contour inside this, only in this surface actually. So in this case, it doesn't matter because we just have this surface here. But this auto range also, you will see it will automatically select between minimum and maximum usually. And if I uncheck this range, I can change this value to, for example, less than 302, for example, save and display. So you will see only this part will be shown here, but I will keep this auto range and save and display this value here. Just let me display again, save and display. Okay, one more thing here. I can close this window and display the mesh, for example, like this. Open it again. So if we have one geometry like this and we want to show the contours and the geometry together, so if you simply just click here, you will see the contour like this one. And one more thing here, we have this coloring, banded and smooth. So just let me disable these contour lines. I don't need this one, so I will display it again. If you are going to actually draw your mesh here, there's an option here. So you can select this one and display the mesh like this. Just click here, select your surfaces, and then display. You will see the geometry beside the contour here. So I can close this one, open it again. So this time I will deselect this draw mesh and just simply draw this contour without the mesh. But there are two options here in the coloring side, banded and smooth. If you select this banded type, so I will select this one and display, you will see there are some division between from left to right of this contour. But if you select the second option, so this contour will be smooth and the coloring has been changed smoothly like this one. So this is for this contour. Also, you have this legend here. So actually we call it as color map. So we can change some settings also here. I can go to color map here. Then, for example, I can change the number of the format of these numbers here from exponential to like a float, for example, here, and then you can select the precision for this one. I will increase to 3 or 4, for example, and then apply. So you will see it will change to the float number with 4 precision at the end. So now I can close this one and close. And next task is actually creating one XY plot. So you can go to the plots and the XY plot, or you can go here and select the new. So I will select this one. So in this window and in this option, you can call one name for this XY plot. I will keep this one as X as a default name. And then as I'm going to show the temperature variation from left to right in the X direction. So this plot direction is in the X direction. So I will keep this default as 1. And I'm going to show the temperature. So I will change this pressure to temperature. Again, a static temperature here. Then I can select this symmetry bottom or top to show the temperature variation here. So you will see this values is changing and decreasing from left to right, from this value to 300 Kelvin. You can also do some changes for this XY plot. In the axis, for example, if you go here, if you select the X, so you can change the format of this X direction. I'm going to change this value in the Y direction, so I will select the Y direction. So I will change this exponential to the float and then precision to the 4. I will keep this default setting as I discussed regarding this auto range. So it will keep this value, and then I will press on the apply and then close this window and then save it again. So you will see it change to a float number like this one. There is another option here, write to file. If you select this one and check this write to file, so you will see this save plot will change to the right. So you can write this the value of this plot in a text file. So you can just click here and just call temp xy plot, call for this one, and it will go to the Workbench working folder. So I will click on the OK, it will be saved. I will uncheck this one, save plot again. And if I go to the working directory and move up one folder up, so you will see the new folder has been created, Fluent, and this temperature XY plot is also here. So I can open it with one notepad software like Notepad Plus, and you will see all these actually values in one notepad file. You can use it in Excel file or everywhere for these values. And now it's time to close this one, and also I can close the Fluent. So I will select the second one, use setting change, the change that I have made for this setting for this current calculation and future. So I will click on OK, wait to close this Fluent launcher and Fluent software, Ansys Fluent. Okay, now we are in the Workbench in this parameter set and project. So this setup has been checked. Now I can right click here. It's ready to update. I can update the solution also here. So it's now updating the solution. Here you will see at the bottom left. And now the solution is ready. And if I go back to this parameter set, you will see this output value that we have set as a parameter also have been updated to this value. So the last part is to change this input value and get our results for different actually values here for this temperature. This temperature of this wall left, this one, wall left temperature. So to do, I can put the new numbers. So this is actually our fine mesh, but I can click here and put this value to 4 and this one to 40 and this one 3 and this time this one to 30. You just click here, double click, and then put your number. Click on other part of the window. And now you have the data for this current calculation. You can retain actually the case and data file for the new simulation for this DP1 and 2. We click on this tick here. But I'm not going to save this data. So I'm just going to get the data here. so I will keep it as it is without check mark. So these two also ready to calculate. So in this case, you can use this update all design point, and then the workbench will be update this value automatically. And you can also click on each of these design point and then select update the selected design points like this, just this one. But in this case, I'm going to update all design points. So I will click on this update all design point, and you will see again here the red light has been started. So now it is working, and so we should wait for the new result. Okay, so now everything is ready, and we got our results for two other design points. And as you see, the number of mesh will not affect so much on the result of this temperature of the wall left, as you will see here. So final thing is this results. So you can update also this result with updating this part, and also you can edit this part also. So I have updated this part, but for this result, I will go again and open this results part. You'll see the CFD post will be a start this time. So there are a lot of options to go through post-processing, but in this tutorial, I'm not going to use this CFD post for the post-processing, so I will close this one here. So in this step, I will save the this project in the workbench, and then I will go again to the solution of the Fluent, and then go to again to the graphic contours. You will see this contour again here. I will display this value. So now let's talk about the top and bottom walls of our domain. We are modeling actually 1D steady state heat conduction, meaning heat is only supposed to flow from left to right, from here to here. So to enforce that, we set the top and bottom boundaries as symmetry, as you saw here. Boundary condition, we have two symmetry boundary condition. So in Fluent, a symmetry boundary means there is no heat flux and no variation normal to those boundaries here, top and bottom. In other words, heat cannot flow up or down, and temperature doesn't change in the vertical direction, as you see. And the only variation is from left to so this two symmetry keeps the problem strictly one-dimensional, exactly as we want it. So it is also more efficient because we avoid unnecessary wall effects and keep the focus on conduction through the length of this material. So it was the last point I was going to mention in this tutorial. All right, that brings us to the end of this first tutorial in the Ansys Fluent Academy Beginner CFD Series. I know this video was quite long, over an hour and 20 minutes, but that was intentional. Even though this is a very simple steady state conduction problem, I went into a lot of detail, especially for those of you who are just getting started with Ansys Fluent and Workbench. We covered everything from input detail and boundary conditions to mesh strategy and the reasoning behind this symmetry to help beginners and students really build a solid foundation. In the upcoming videos, we will go much faster and skip some of these basic explanations, so don't worry. Not every tutorial in this series will be this long. So thank you so much for sticking with me through this first video. If you found it helpful, make sure to like, comment, and subscribe, and check out the full playlist for more tutorials on laminar pipe flow, convection, supersonic flows, and more. So I will see you in the next video where we will move on to a more dynamic flow problems. So take care and happy simulation.